In this problem, we're given that the point negative 60 comma negative 91 is on the terminal side of an angle theta, and we need to find the exact value of the following trig functions. So I'm going to do the first couple and hope that you can do the rest on your own. So it turns out I never need to know what the angle theta is to find the sine of theta. I just need to be able to draw a reference triangle, label its sides, and then go from there. So it turns out that our reference triangles always share the x-axis. So for example, if my point had been in the first quadrant, it isn't. In fact, negative 60 comma negative 91, if you were to plot that, negative 60 would be over here, negative 91 would be down here, negative y value, it's in the third quadrant. But if you ever had the point in the first quadrant, what you would do is you always connect the point to the origin, and one side of the reference triangle is always the x-axis. So this would be your reference triangle if the point was in the first quadrant. Had the point been in the second quadrant, again, you'd connect the dot to the origin. The x-axis is always one of the sides of the reference triangles, and you would form a triangle out of that, and this would be your reference angle right here. So here is the reference triangle if your point is in the first quadrant, and there's its reference angle. Here's the reference triangle if the point was in the second quadrant, there would be reference angle. I'm going to move to the fourth. If your point was in the fourth quadrant, you connect a line segment from the origin to that point, and since the x-axis is always one of the sides of a reference triangle, you would have that, and you would have this triangle, and this little bit right here would be your reference angle. Now, to our problem, our problem has the point negative 60 comma negative 91, which puts it in the third quadrant. So connecting the dot to the origin and then using the x-axis as one of the sides of the triangle, I would complete my reference triangle by drawing a line down. And it turns out for this problem, this is my theta that I'm worried about. Now it turns out that the sine of theta is equal to the sine of theta prime. A lot of teachers like to call the reference angle theta prime and point out that the sine of theta is equal to the same thing you'd get if you did the sine of theta prime. Now to label my sides, the fact that this is the point negative 60, negative 91 means that this side of my triangle here would be labeled negative 60. And this side here, since the y value is negative 91, this side here on the triangle would be labeled negative 91. So if I was to sort of get rid of all this other information and just look at the triangle, I really only need to have this piece of information here that I'm trying to find in the first question, the sine of this angle, which is the opposite side over the hypotenuse. So this would be the opposite side over here. I need to figure out what it is and divide by the hypotenuse. Well, we already know the opposite side is negative 91. Later on in the question, I'm going to need to know this side right here, which is the adjacent side. Let me label that ADJ. That's negative 60. And then, of course, the side opposite the 90-degree angle is my hypotenuse. So for the first question, sine theta, I'm going to argue that the sine of theta is the same as the sine of my reference angle here, theta prime. So since the sine is opposite over hypotenuse, I already know the first piece of the puzzle. I know the side opposite my angle is negative 91, regardless of what picture you're looking at. The thing I do not know is what the hypotenuse is, so that's a whole other problem off to the side, and involves the Pythagorean theorem. If I know this side is negative 61, and I know that side is negative 91, I can use the Pythagorean theorem to find the hypotenuse. So that would look like this. I'd have, by the Pythagorean theorem, the negative 61 squared plus negative 91 squared equals my hypotenuse squared, which I don't know the hypotenuse. That's why I'm just going to label it h. If you let me just use h for the hypotenuse, I have this squared plus this squared equals the hypotenuse squared. So to find the hypotenuse, I'd have to solve for h, which means I'd have to take the square root of both sides. So if I take the square root of the right-hand side, I'm just going to be left with h, but I have to take the square root of the left-hand side, and I'm not a human calculator, so I'm going to have to switch over to my calculator and tell it that I want the square root of parentheses negative 61. I know you're not seeing all the keys here. added to negative 91 squared. And since when you square a negative it becomes positive, you actually could, for this calculation, leave the negatives out. And I press enter, and I get that the hypotenuse is about 109.55 units. So I get that our hypotenuse to 2 decimal places is 109.55. I'm not sure that MathAS is going to be happy with 2 decimals, so you might need to give it more. So that number goes down here in my denominator. My hypotenuse, I solved for it, and I got 109.55. So the hard part is done. I have the opposite side labeled, the adjacent, the hypotenuse. It's just a matter now of going through and memorizing the definition of all these trig functions and what ratio I'm supposed to form. Since I'm doing the sine function, the ratio is opposite or hypotenuse, so for that question, the answer is negative 91 over 109.55. So just to make it so the video is not so long, I'm not going to do all these, but since I already have the 109.55 in my calculator, I just need to take negative 91 and divide by that answer. So negative 91 divide by, now if you don't know how to get previous answer on your calculator, it's second negative. And I know the video's cut off, but just below the number 3 in the keypad is the negative sign. If you press second negative, you get previous answer. So I'm guessing that the sign comes out to be negative 0.83. So this answer would be roughly negative 0.83. And I'm assuming that MathAS might want more accuracy than that, but to 2 decimals, that should do it. Now the cosine, not to make this video really long, what's the cosine? The cosine is the adjacent over the hypotenuse. So if I was doing the cosine function, I would need to do the adjacent side over the hypotenuse. And we've already figured out that the adjacent is negative 61. And we did a lot of work to figure out the hypotenuse was 109.55. The tangent function is defined to be the opposite over adjacent. So it would be the opposite is negative 91. And the adjacent side is apparently negative 61. And this just continues on. One thing that you may have learned is that the cosecant function is actually the reciprocal of the sine function. So if you just took this fraction and reciprocated it, you'd get the cosecant. So the cosecant of theta would be just the reciprocal of this, which is 109.55. Sorry about that. Try this again. 109.55 over negative 91, and you could go to your calculator, type that in, and try to get as many decimal places as MathAS wants. And then the secant, turns out, is the reciprocal of cosine. So whatever your answer was for cosine right here, you just reciprocate it. So since cosine is adjacent or hypotenuse, the secant function is the reciprocal, meaning it's the hypotenuse over the adjacent. So you would just flip these. And the cotangent is the reciprocal of tangent. So the tangent is opposite over adjacent, so the cotangent is adjacent over opposite. So you would just write this answer except it's reciprocal. You'd write negative 61 over negative 91. So kind of a messy video as far as handwriting, but hopefully the explanation was good, and I hope that gets you through this problem.